and we'll get started here. So if you're seeing my screen, you're seeing this
Yep.
calculate the volume of a right circular cone with height 10 and base radius 5. So this seems out of scope, but the volume of a cone is 1/3 pi r squared h. And the reason this is important that it's a right circular cone is if it wasn't, sometimes they give you what's called the slant height down the side instead of the height, and you actually want the height. So here, though, that you got all the numbers, it's just 1/3 pi 5 squared times 10. So it's 250 pi over 3. Maybe they're just trying to get used to the fact that answers aren't always nice. Here. Okay, let's go to question number 2. Question number 2. So set up. I don't know why this is. Set up integrals to find the surface area of the surface obtained by rotating the curve about the y-axis in 2 different areas. So this one wants the surface area.
Mhm.
And you know, full disclosure, I don't remember the formula, so I got to go look for it. Surface area integral. I always go to this. I think I've told you this many times. This math Lamar, and these notes they just give you the that's calculus 3. You don't want that yet. Okay, so here we go. The formulas are given here. Actually, let me throw them up to the right here. So these are your formulas here. Whether you're rotating it about the x-axis or the y-axis. Okay. And then you use these formulas here. Now, I guess I don't follow this. Why it says y-axis in 2 different ways.
Oh, that means doing it in where are the equations in terms of x and y.
Yeah, but then you're rotating it about a different axis. So maybe that's what was meant here. Like do it for the y and then do it for the x.
No, we've done this.
Okay.
She just wants you to solve for x in the equation and then.
Okay. So
Yeah.
yeah. Okay. Well, now I follow what you're saying here. I see. Okay. Yes, that is.
It makes it more difficult, but
sure. So
yeah.
So if we do about the y-axis, okay, the surface area is the integral 2 pi x, and then there's this ds. And your ds is when you solve this thing for x, okay? And then this other one is when it's solved for y. So in short here, how do I explain this here? Your x, from what I remember, let me just do a quick check. From what I remember, x really isn't x. X is like x equals in this problem. So y equals, yeah. So we're actually doing, the first one we're doing, we need to solve this for x. Does that sound right to you?
Yep.
Yeah, natural log y over 2, and then -1. So that's your x in this one. So this is really, it's really 2 pi natural log y over 2 -1. And then your ds has to be in terms of y. So it's times the square root of 1 plus, and then we got to figure out this dx dy. So we got to take a derivative of this. The derivative dx dy is 1 over y over 2 times 1/2. So it ends up just being 1 over y. So 1 over y squared.
Or why is it times the half?
Chain rule. So the inside, the inside part is 1/2.
Okay.
And wow, this is horrible. Yeah, so where do you go from here? I don't know, without thinking a little bit harder about this. But but that's one of them, we'll
Does it
say.
say, I think it just says set up the integral.
Does it?
Yeah.
Yeah. Okay. Yeah. So that's not possible. So then we, when we need limits, so the limits are the y limits. So it's
Right.
whatever when x equals 1, which would be 2e squared, and then when x equals 2, which is 2e cubed, you got to get your limits in there.
Okay. So it wouldn't be just 15 and 40.
I mean, those are estimates. I mean, but these are the
Yeah.
exact, like these come from putting
Oh, okay.
those numbers, because with respect to y, you need I mean, that's what these end up being,
Okay.
15 and then 40.
So would it be okay to just put those?
Not for me, but maybe your
Uh-huh.
instructor would be okay with it because
Okay.
they're close enough. But
All right.
yeah. So then if we go the other way, if you still don't have that up in front of you, it's still the integral 2 pi, but then we got the y, which is given the 2e to the x plus 1, and then the square root of 1 plus, and then we need to take the derivative of this. So the derivative of that is just itself. And this time it would be from 1 to 2.
All right.
Do you get a reference sheet on this exam?
Probably. I don't think so. Probably not.
Okay, so there's some formulas there to remember there. Okay, let me snip the next one in and get started on that. Yeah, the no big reveal on this exam. I mean, it's like there's just integrals, lots and
Right.
lots of
Yeah.
integrals.
Just basically just remembering the
Yes,
formulas.
yes, yes, and then executing on the exam. Okay, calculate the volume of a right triangular pyramid with height 10, whose base is a right isosceles triangle with side 4. This is the second problem. One was like this where they're asking, this is not a calculus question, like, but do you expect these to be on the exam? I mean, has your instructor been emphasizing this?
Not, it hasn't been emphasized, but
Okay, so the volume of a period is 1/3 the area of the base times the height. So
yeah, this is like the first things that we did.
yeah, so the base is a right isosceles triangle. So B in this case is 1/2 4 times 4, which is 8. And then the height in this case is 10.
Uh-huh.
So it's just 80 over 3.
Okay.
Now there's others. There's cones, there's cylinders, there's spheres. I guess I don't know what to tell you to think about, or to like which ones to know, but you need to know like a lot of them.
All right.
Okay, so yeah. So 4 is kind of like 2. Let me do this one a little bit better than I did the last time. Like let's just start with the integral 2 pi y this time. And so it's 2 pi sine x squared. Okay, but then your dx is this 1 plus, and then you take the derivative of this thing right here. Okay, so derivative of sine is cosine of x squared. Derivative of x squared is 2x, and then this is squared dx. And because it's an integral in dx, you just use the bounds that are given here. So I'm just going off of the 0 to square root pi over 2. So that's the first way. The second way is to solve it for x.
Right.
Okay, and that's what we'll do next year. So x equals the arc sine of y, and then you're taking the square root of that. This is already horrible, but this, this is what it is. And that's why it says probably just to set up again, not to do anything. So
Yeah.
integral 2 pi x, remember it's x equals, so it's 2 pi arc sine of y. And then this time it's the square root of 1 plus, okay? And we got to take the derivative of this thing. So sometimes it's good to rewrite it just as a refresher here. It's really all to the 1/2 power. So it's power rule, okay, arc sine of y to the minus 1/2. And then you have to take derivative of arc sine of y, which is like 1 over square root 1 minus y squared. Might need to check that. Derivative of arc sine. Let me check here. So it's kind of a, it's kind of a, yeah, that's it. This is kind of a, for teachers, they or instructors, they're like, yeah, like you got to learn, you got to remember your derivatives because there's all this,
Right.
you got to do it in here. So it's a way to kind of reinforce, hey, you need to remember all that stuff. It's okay to leave it super messy. We do need the bounds this time. So the bounds are from 0 because we can truly say that that's at 0. But then it's the sine of the square root of pi over 2, but then that's squared. So sine of pi over 2 is 1. Sorry, 0 to 1. So at least the limits are nice.
Yeah.
Whatever that's worth here. All right. Go back to your guide here. Okay, arc length. Yeah, so here's another formula for arc length. All right, calculate the arc length of the curve. So again, these is just another one of those things you gotta go and look for. I used to know these like really well, but there's very few calculus 2 students anymore. Either students don't need, a lot of times students don't even need this class unless you're going to engineering or physics. So, if you get out of school and you may find that people don't even remember this stuff when you get out. So
Yeah.
the arc length is again the integral of ds, and this is very similar to the last one. Ds is either 1 plus dy dx squared, which is what we want in this case, dx, or if it's given in terms of x, you would be dx dy squared dx. So in this problem, like all you literally need is the derivative of this. You need your y prime. Your y prime is 2x minus 1 over 8 times 1 over x. Okay, and then what I like to do is I actually like to square it before I write all this. So you're squaring this thing, this 2x minus 1 over 8x squared. So if you remember how to do that, a minus b squared, it's a squared minus 2ab plus b squared. So this becomes 4x squared. And then you multiply the two inner terms here so that the x's actually cancel. You get negative 1/4, but then you double it, so you get minus 1/2 plus 1 over 64x squared when you square the last one. Okay, so it's the integral of the square root of 1 plus all this stuff here, 4x squared minus 1/2 plus 1 over 64x squared dx. And in this problem, we'll get the limits in a minute, but I don't remember what I was going to. This is very important though, is like this inside part, you're going to end up, it should turn into something squared inside the square root. That's our goal here. You probably saw that in class. So just a little bit of rewriting here. Let's see here. Let's go 4x squared plus 1/2 plus 1 over 64x squared. And this is where this is not a calculus thing. You got to just figure out, well, how do I rewrite this? Well, it's 2x.
Isn't that a perfect square?
It is perfect squares.
She put that on our quiz last week, and she was like, I put an extra question on there. If you don't know how to do it, then just don't do it. I was like, oh, okay.
Well, it's basically like what we did here, except it's like you can see the similarities. I'll put it in red here. It does tend to be like this when you take this class. Like there's only so many options that they can do. So like it wouldn't surprise me if you got just a change of sign here, but this whole mess under the root, which simplifies to this, can be rewritten as this, and then you're square rooting it each step along the way. So the square root cancels out the square. So we're using either a plus b squared or a minus b squared. These are the the two possibles that you could see on there. Okay. So then your integral. So it becomes just the integral of 2x plus 1 over 8x. And we're doing that. Oops, I didn't write my dx in any step here. Dx. Then we go back. It was from 1 to 2. 1 to 2 here. Okay, so this is now power rule. This one is really 1 over 8 times 1 over x. So that's 1/8 natural log absolute value of x. You evaluate that from 1 to 2. 2 squared plus 1/8 natural log of 2 minus parentheses 1 squared plus 1/8 natural log of 1. Natural log of 1 is 0. This is 4. This is 1. You're subtracting, so you get 3 plus 1/8 natural log of 2. The other variation that they sometimes give you on these is an e exponential to complete the square on it, or a factor, perfect square trinomial, or a polynomial, like you just saw there. I would definitely work out this example again, because this one you actually do have to go through all the steps.
All right.
Get down to your final answer with that. Okay, on to number 6, or
Yep.
Great. Set up integrals, one using disk washer method and one using cylindrical shells to find the volume of the solid by rotating the region bounded by the curve, the y-axis, and the line y equals 1. So they didn't graph that. There's your line y equals 1 about the x-axis. So what I like to do is actually show the shaded region, show which I'm rotating about, because I mean, believe it or not, you would, in your stressful situation, you may forget. Okay. So the more straightforward one here is probably disk washer. Okay, so your big R is this radius right here. So that's just 2. And then your little r, getting the right color here, is this distance here. It's the green. So that's the 1/2 x cubed. Okay, so the disk washer method here is the integral big R squared minus little r squared with a pi. Okay, so in this case, it's going to be integral 2 squared minus 1/2 x cubed squared. I'll put the pi out in front. Our bounds go from 0 to, well, wherever these intersect here. It's not quite at 1. Anyway, so it's 1 equals 1/2 x cubed. Like you might think it's 1, but 1 is like right there. So 2 equals x cubed. So it's, I'm sorry. Yeah. So x equals the cube root of 2. So that's your other bound. Like this number right here is the cube root of 2. Is that okay?
Yep.
Okay, so that's the cube root of 2 there. dx. Okay, so you got 4 minus 1/4 x to the 6th. So you got to find your antiderivative 4x minus 1/28 x to the 7th pi, and you're evaluating from 0 to 3 square root of 2. Oh, that's horrible. Oh, set up. I'm sorry. I'm going way too far. Yeah. I just mentioned, oh yeah, pay attention to that. Yeah, pay attention to this too, because it's obviously a lot harder to do that. So now we need to do the method of shells. Okay, so the method of shells here, let me grab the question again. Okay, so when we're going around the x-axis with shells, I think we got to make everything in terms of x. Can't remember, like it's integral 2 pi x h. Let me go look.
Yes.
I need to go look because I don't remember. And I don't want to tell you the wrong thing. So
I don't think it has to be X, or maybe I don't know. We have. I don't remember.
I'm just going to my resource here.
I think it's 2 pi radius times h is what it is. You determine what the radius is.
Yeah, when we're going around the x-axis, it's 2 pi y, and then you need the other one, the other dimension here. So they call it width, but it is your you have to get this in terms of y, I guess, because it's your height has to be in terms of y, I guess, is the thing that maybe isn't clear when you're going about the x-axis. So what that means is you got to solve this for x. So x is the cube 2y to the 1/3 power. So our integral goes from 2 pi y, and then it's 2y to the 1/3 power dy. And then your limits of integration come from the y value. So in this case, it is just 0 to 1 because of that distance there.
All right.
So again, set up. That's as far as you need to go, as far as I can tell. It's easy on them to grade. If you just set it up, they can just, check, oh yeah, he did it or he didn't do it.
Right.
All right, so 7 is another arc length curve. This one is in terms of y though, but it doesn't change the way you do it. So the arc length, this is your x. You immediately want to find x prime, or dx dy. So your derivative is 1 plus 1 over 1 plus y squared. So that's why I got to know your derivatives.
Right.
And your length is the integral of ds, and ds is square root of this thing squared. So I mentioned this before, I like to square this before I plug it in here, which maybe doesn't seem like the right step, but we're going to just do it anyway. So it's 1 plus 2 over 1 plus y squared plus 1 over parentheses 1 plus y squared, like that. That's just your a plus b squared formula. Okay, so then, oh, I'm sorry. This is just another setup. I'm going way too far. When it's just a setup, you don't need to do that. 1 plus 1
She
over
said
1.
most of them are going to be just set up.
Yeah.
And then she said that perfect square one, that she said that's probably the one that we're going to have to solve.
Okay. So if you set up, you don't need to square it. You do need the dy. You got to be very careful to get that. Right. You do need your limits of integration. They're definitely going to be grading for that. All right, so let's go to number 8.
So arc length seems pretty easy because
Yeah, it's just the
just
integral
plug in the equation.
ds,
Yeah.
and in most of them they're actually impossible to do by hand, so you end up just using a calculator, meaning like an estimate of it, but it's pretty good. Okay, this one's going back to surface area. So like so far we've seen like volumes, meaning like shells, disk washer, and now we've seen some arc length, and we've seen some surface area. Maybe the exam will be a little better organized, but I would try to do all the volumes, all the shells, all the arc,
Right,
like
yeah,
do them all
do
together.
it.
But like if there's two arc lengths, hopefully they're right next to each other, rather than it's
Uh,
question 2 and then 7. So
is washer the one where it's big R minus
yes,
little r? Okay, cool.
yes, yes. And it should say, it really should be solid disk. I don't know why I think that a disk isn't always solid, but yeah, just maybe that's just me. So this one, we're integrating about the y-axis. So that's integral 2 pi x, okay, and then ds. But it's not x, it's x equals is what this refers to, which is what we have here, e to the y. So this is integral 2 pi e to the y, and ds is that thing we were just doing. It's that 1 plus, okay, and then it's the derivative of this thing squared. So it's e to the y squared dy. So ds, just to be clear, ds for arc length and surface area is exactly the same. It's the same ds. So then we need the limits of integration. They just tell you them there, 0 to 1. So just set it up. You're done.
All right.
Okay, so up to question, going to 9 now. Let's do that. Apologize, I'm having a little issue here. See if we can paste it. There it is. Okay. Calculate the volume of the solid obtained by rotating the region about the line y equals 2. So there's the line that we're rotating about. And notice that it's parallel to the x-axis. So we want to first treat it like it's a disk washer. In this case, it's a washer. There's your big R, and there's your little r. So your big R, well, we need to figure out, well, which one is this line? It's the straight line. It's the x plus 3. The problem is, though, is x plus 3 is relative to the x-axis. So like if you put 0 in for x, you get 3. But we don't want 3. We want the distance from here. So it's really x plus 3 minus 2. You have to subtract that distance there. So it's really x plus 1. And then the same thing with the little one here. It's x to the 4th plus 3, but that would give you the full 3. And we know that we need to subtract 2 from it, x to the 4th plus 3 minus 2. So it's x to the 4th plus 1.
So why did you just subtract 2? Is it because the line is below both of the functions?
Because this y right here is from the x-axis. So like if you put y of 0 in, you get 0 to the 4th plus 3, which would be 3, which is this distance right here.
Uh-huh.
And we don't want that. We want just this little piece.
Okay.
So we have to subtract out what we don't want.
Oh, okay.
If it was above it, this is where it gets complicated. If it's above it, it's up here. It ends up being that number minus this.
Right, because it's higher. Oh, this is like a
higher.
high low thing.
Right. But if we were going about a line down here, we would then add it to this because it's the radius plus this little bit.
Right.
So there's like a couple of different cases. You're either subtracting it, subtracting your y minus something, or it's y plus something. That's just the way it is. So we integrate from 0 to 1. Pi, big R is x plus 1 squared minus little r, x to the 4th plus 1 squared dx. Okay, and this one we actually have to come up with. We actually have to get the answer. So this is x squared plus 2x plus 1 minus x to the 8th. This is 2x to the 4th, but we're negating it, 2x to the 4th plus 1 minus 1. So notice these cancel, and you're left with this right here. So you want to find the antiderivative. So I'm gonna kind of change the order. It's minus x to the 8th minus 2x to the 4th plus x squared plus 2x. So this would be minus x to the 9th over 9 minus 2/5 x to the 5th plus 1/3 x cubed plus x squared from 0 to 1 times pi. Now, thank goodness at 0, these all cancel. So it's minus 1/9 minus 2/5 plus 1/3 plus 1. So your common denominator here looks like it's 45. So that's minus 5, okay, minus 18 plus 15 plus 45. So you got 60, take away 23, whatever that's 30, 37 over 35 pi. Okay, and then because we got to do it two different ways, the whole point of this exercise is like, well, you should get the same result because shouldn't change whether you're doing this method or the other. So because it's with respect to the x-axis with the shells, we need to solve both for x. So this first one is going to be x equals y minus 3 to the 1/4 power. And then this other one is going to be x equals y minus 3. Okay, so the way you do these curves are, it's right minus left. You remember that? So it's this curve, y minus 3 to the 1/4 minus parentheses y minus 3.
Or how do you tell which one's right and left? When they're
Well,
on top of
like,
each other?
yeah, that's where it's kind of like, what do we say here? So if you were to rotate your page, it would be clearer, which obviously I can't do. Yeah, you will find it doesn't work the other way. You'll get like negative of the answer.
Okay.
Also, that's not really the right. I mean, I'm kind of not giving you good information, but yeah, I mean, we really want it to be a nice, clear, like, oh, well, that's, that's, but if you were to rotate, everything that way, you would see it.
And this is happening because it says solve in two different ways.
Yes.
All right. I think I might be remembering wrong, but I think she's just doing that for the sake of practicing doing it with
yeah.
In terms of X and Y. I don't think the questions will be like that in the exam.
Okay.
But I don't know.
Let me just set this up real quick. So it's from 3 to 4, 2 pi. Now it's not y, because y gives you this right here. It gives you the distance from here, and you don't want that because it's got to be y minus 2 because you're doing this one. And then that's where this y minus 3 to the 1/4 minus y minus 3 dy comes in. Yeah, I don't even think you could do this. You probably meant to set it up. I mean, I don't think you can do this by hand very easily. All right. 10 is actually really a physics problem, but they throw these in.
This is something we just did the last 2 days.
Okay, you go rock climb with your friend. You bring a 50-meter long rope with a mass of 1 kilogram per meter. Your mass is 75 kilograms and your friend's mass is 100 kilograms. How hard in joules would you have to work to pull your friend attached to the rope all the way over the edge of a cliff? How hard joules your friend to pull you?
These problems we use the integral to solve.
That's right. It's the work equals the
Right.
integral of f dot dx or f dx. And let's see here. So you it's mg weight equals mg. Associated gravity is 10. All right. I need to just quickly study a relevant problem here, and then I can help with this in just a moment here.
That's fine.
Do they give us the, okay, so the, oh, they do, they give us it's 1 kilogram per meter. Okay. Yeah, so so sometimes they give you the mass of the rope and the length, but they take that into there. All right, so the force in this problem is the distance lifted, okay, times the weight per foot of the cable. So it's the distance lifted times the weight per foot, which we are, or weight per meter in this case. Okay, so the distance here is, why is there a 2 in this problem? Huh. Zero, it's 20 feet below. Oh, it starts at 10, lifted 10 feet. So I believe it's x minus 50, and the weight per meter is that weight of the rope. But why? It's like your instructor's asking this relative to something else. Let me go search another thing here and see if I can give you some more information. Oh, don't we? I think we have to add in the mass over the length. Because so the rope itself is 1 kilogram per meter, but we have to take into account that there's 100 kilograms also over 50 meters, which is another 2 kilograms per meter. That may be it. Do you have the answers to these also? Trenton, not sure if you heard me. I was just asking if you had the answers to these.
Oops, sorry, I muted myself.
That's okay.
Yes, I do. What number is it again?
10. Do you have it worked out or just the actual answer?
I think worked out. Hang on. There's so much. Yeah, I have it worked out.
Okay. Would it be possible for you to send that to me so I can kind of step you through it, show you where the numbers go? Either text or email or.
Does putting in chat work?
Chat's great.
Yeah, I have to use the full document, so it's at the very bottom.
There it is. All right. Yeah, so your instructor isn't doing it. I don't know. Okay. How hard? Okay. So I guess your instructor is doing it both. I don't know. Let me set up the instructor. Okay, so the instructor is doing it a couple ways here. The first thing they're showing you is that work is force times distance, and your force is mass times acceleration times distance. So when you're pulling your friend up, your friend's mass is 100. The acceleration is 10. I'm sorry. Oh, it says to pull you up. So you're not 100, you're 75. And then the distance is 50. And that equals 37,500 joules. And then similarly, to pull your friend up, okay, it's F times D, force is mass times acceleration, you know that from your other class. Your friend's 100 kilograms, acceleration is 10, and the distance is the same, it's 50. So that equals 50,000 joules. Okay, now, if you actually want to do it the way that they are talking, the way that they're using in the integral approach. So the work is the integral from 0 to the distance that you're pulling them. Okay, so I'll fill in the numbers here. It's 0 to 50 because that's the distance. Okay, and then it's the mass times the acceleration. Now, the mass changes because you're pulling that rope. So when you get to 50, the mass there's nothing on the end of the rope. So this part is the 50 minus X. It's really the distance minus X.
I got a quick question.
Sure.
Would you not add in the work it takes to pull the weight of the rope as well to it?
So that's coming up next. That's the one. That's the 1 kilogram per meter. So like when the person's all the way at the bottom, they're contributing 50 kilograms. When X is 0, they're contributing 50 kilograms plus the 1 kilogram from the rope. Okay, so that's 50 minus X times 1, and then your acceleration is the 10 again. Is that okay?
Yep.
Okay, so then the only difference, I guess, to this is the only thing that's different, I guess, here is now you're gonna integrate. So it's 500 minus 10x squared. So it's 500x minus 5x squared, evaluated from 0 to 50. You might need a calculator. So you end up getting 12,500 for that. And what they're trying to show you here, I guess the maybe the thing that's most important here is there's actually 3 works that they're talking about here. How hard is it to work pull your friend? How hard would your friend have to pull to work?
I remember her saying something about for since the weight of the rope is changing as you're pulling it up.
Yes, that's this part right here.
That's how you have to do the integral for it.
Yes. Whereas the other ones you can just it's the same
right
each time.
Right.
So it's a more standard question is this one. Like they don't ask about you or your friend. They just or they like it's just pulling up someone of a certain distance. Because the 50 is the distance it's meters, and then the other units are of the rope are kilograms per meter, and so you end up getting a cancellation there with the units. All right, let's I guess quickly talk about 12. And this is the only time you see these work integrals. They're not part of this, and they only come up again in advanced physics classes. They don't really come up in your mechanics. They just give you the mass of the object. All right, so the amount of force required to lift a backpack from the floor to your shoulder, so you're going up this way, is modeled by this function right here. Okay, so to do this analysis again, it's did they give you the units of this? Oh, so this is your force. This is your force equation.
Oh, okay.
So you're integrating your force equation, which is F dot dx. Okay, and you're integrating from 0 to the distance 2, and then your F, I'm sorry, F is this y squared minus y plus 1, and dx is really just means could be any variable dy. So the only kind of variations you might see in this problem is like, let's say you started 1 meter above the ground and you went to 2 meters, you would just integrate from 1 to 2 kind of thing.
All right.
You didn't do any problems like where you were pumping out something out of a tank?
No.
Okay, maybe they're coming or they're not coming, or I don't know. All right, this key actually looks pretty good. I would definitely recommend looking it over again, comparing to stuff we did. Hopefully I didn't miss anything. Wow, your instructor actually did one of these 4th roots of y minus 3. Wow, how horrible. Okay. The question is this 9. Question 9 is like a 3-page long solution. You might look at that.
Oh yeah, that's right.
If you got time. You need to get to sleep. You can just.
Oh man, that looks fun.
Yeah. Right. How's everything going in physics?
Not that good.
Okay.
Well, it's just the teacher, I studied so hard for this exam. We just took it today actually. And I studied all the homework, and then he gives a review packet. And then the tests are just nothing like anything that we went over or even studied. Nothing like the homework. Everyone's having the same problem too. It's not just me. So